Jupiter is a lie we were all taught to believe. It hangs in the night sky like a familiar god, striped and serene, a massive ball of gas floating quietly beyond Mars. At least that's how it was framed in classrooms, textbooks, and childhood diagrams. A gas giant. A simple label, comfortable, reassuring. But the universe has a habit of punishing our comfort, and Jupiter, more than almost any other object in our solar system, exists to remind us how wrong our intuition can be. Because Jupiter is not a giant ball of gas. It never was. And the truth is far stranger than anything most of us were prepared to hear. Please like and subscribe because this journey will change the way you see our place in the universe. Brace yourself. Here we go. This is not a request made lightly or for algorithmic vanity. It is an invitation to let go of what you think you know and step into a deeper, quieter form of wonder. Over the next chapters, we are going to descend not just through the clouds of a planet, but through layers of assumption, habit, and intellectual inertia. If you stay with me, you will never look at Jupiter, or planets, or even matter itself in quite the same way again. The word gas sounds insubstantial, ephemeral, something you can pass your hand through without resistance. We imagine Jupiter as a swollen balloon, held together only by gravity's patience. But this picture collapses the moment we ask a more honest question. How does something made mostly of gas become heavier than every other planet combined? Jupiter outweighs all its siblings added together. It contains enough material to build more than 1,000 Earths. Its gravity sculpts the solar system, shepherds asteroids, deflects comets, and quietly dictates the rhythm of planetary motion. This is not the behavior of something flimsy. This is the behavior of a titan. And so the first crack appears in the story we were told. When we look at Jupiter through a telescope, all we ever see are clouds. Beautiful, turbulent, endlessly moving clouds. Bands of white and brown, storms that dwarf continents. The great red spot, swirling for centuries, like a cosmic wound that refuses to heal. These visuals are hypnotic, and they have distracted us for hundreds of years. We assumed the surface was the planet. We mistook the mask for the body, but Jupiter has no surface in the way Earth does. No ground, no place to stand, no clear boundary where above ends and below begins. Instead, it is a continuous descent, one state of matter, melting into the next, pressure stacking upon pressure, gravity tightening its grip with every kilometer. What we call Jupiter's atmosphere is only the faintest skin, a fragile veil measured in mere tens of kilometers, draped over something unimaginably deeper. Beneath the clouds, the gas thickens. It grows heavy. It resists motion. And then, without ceremony, without warning, it stops behaving like gas at all. It becomes liquid. This is the first conceptual vertigo. A liquid planet, an ocean not of water, but of hydrogen, the simplest element in the universe, forced by gravity into a state that feels almost like defiance. On Earth, hydrogen is slippery, volatile, eager to escape. On Jupiter, it is trapped, compressed, disciplined into obedience. Pressure is the unseen sculptor here. Gravity piles weight upon weight, squeezing atoms so tightly that the very rules of chemistry begin to blur. Temperature rises, not because of fire, but because compression itself generates heat. The deeper you fall, the hotter it gets, not from a burning sun, but from the planet's own mass bearing down on itself. And this is where the story becomes unsettling, because even liquid is not the final answer. As we descend further into Jupiter's depths, pressure climbs into the millions of times greater than anything experienced at Earth's surface. Atoms are no longer allowed their personal space. Electrons, those loyal companions orbiting atomic nuclei, are torn free. Hydrogen stops behaving like an element and starts behaving like a metal. Not metaphorically, literally. A liquid metal ocean, electrically conductive, shimmering in theory, invisible in practice, and utterly alien to human experience. Jupiter is not just a liquid planet. It is a liquid metal planet, generating the most powerful magnetic field of any planet in the solar system. A field so vast it could swallow the sun if it were visible. Pause for a moment and let that sink in. We orbit a star that is older than civilization, in a solar system shaped by a planet that contains oceans of metallic hydrogen, churning silently beneath clouds that never touch solid ground. A planet where lightning is born not from weather alone, but from the fundamental physics of compressed matter. A planet whose interior resembles nothing we can walk on, swim through, or hold in our hands. And yet, for decades, we taught children that it was just gas. This misunderstanding is not a failure of curiosity, it is a limitation of perspective. From far away, complexity collapses into simplicity. From a distance, Jupiter looks calm, ordered, predictable. Only when we approach does the truth begin to fracture our assumptions. And this is the deeper lesson Jupiter offers us. Reality is layered. What we see is rarely what is. Surfaces deceive, categories comfort us, but they do not define the universe. The cosmos does not care about our labels. It cares about forces, pressure, energy, time. Jupiter exists as a reminder that nature does not owe us intuitions that feel right. It owes us only consistency, and even that consistency operates on rules far stranger than our everyday minds prefer. In the chapters ahead, we will follow humanity's first attempts to truly see Jupiter not as a painting in the sky, but as a physical process unfolding over billions of years. We will witness impacts that shook the planet, probes that dared to fall into its atmosphere, and discoveries that forced scientists to rewrite textbooks in real time. But for now, let this single truth unsettle you. Jupiter is not what you think. It never was. And if a planet this close, this studied, this iconic can hide such profound secrets beneath a thin veil of clouds, what does that say about the rest of the universe? It began with a ghost in the sky, an enormous, spinning spectre we could see but never touch. For centuries, Jupiter was just that, a myth wearing a cloak of clouds. It orbited like a silent guardian beyond Mars, impossibly large, bafflingly smooth. To early astronomers, it looked perfect, untouchable. And then, for the first time, we flew close enough to look into its eyes. In the year 1974, a fragile machine made by fragile creatures crossed the void and took the first close-up image of this monster. It was called Pioneer 11. Small, brave, a scout into the unknown. Through its lens, we caught our first glimpse of the planet, not as a shimmering dot through a telescope, but as a place, a world, a body in motion. 5 years later, Voyager 1 followed with something even more astonishing: movement. A time-lapse of Jupiter's clouds in motion, like cream stirred into coffee by the hand of a cosmic giant. The illusion of calmness was shattered. Jupiter was a storm, alive and pulsing, with bands that swirled, twisted, fought, and flowed like the very breath of the universe. Its surface, if we can call it that, was a battlefield of fluids, painted in every shade of gas and fire. But even these breathtaking views raised more questions than answers. What was it made of? Where did it come from? Why does it move like that? Because nothing about Jupiter behaves the way it should. Nothing is static. Nothing is stable. It is a body in rebellion against simplicity. And as we got closer, it became clear we weren't just visiting a planet. We were confronting an ancient riddle, older than Earth itself. Imagine this. Take every other planet in the solar system: Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune. Add their masses together. Now double it. You're still not at Jupiter's full weight. It is, by far, the heaviest and most dominant planet in our star system. That alone makes it more than a curiosity, it makes it important. Jupiter isn't just big, it is central, foundational. If the solar system were a symphony, Jupiter would be the deep, vibrating note that anchors the melody. To help you feel its scale, let's shrink things down. Suppose Earth is the size of a grape. In your palm, small and familiar. Next to it, Jupiter would be a basketball, massive, radiating presence. And inside that basketball, you could fit 1,000 grapes. 1,000 Earths. That's how much space Jupiter swallows. It isn't just a planet, it's a gravitational empire. So, how does something like this even form? The answer, or at least the answer we used to believe, begins in a cloud of dust. Billions of years ago, our sun was born in the fiery collapse of a stellar nursery, and around it formed a spinning disk of leftover debris, gas, rock, metal, ice, a chaotic carousel of particles swirling in a plane of potential. And then, slowly, over millions of years, gravity began its work. Dust clung to dust, pebbles collided, rocks smashed together and became mountains. The debris gathered itself into larger and larger bodies, growing ever more massive. Eventually, these growing bodies became what we now call planets. Under this theory, Jupiter started just like Earth, as a chunk of rock, but then something special happened. Its core grew so big, so fast, that its gravity started to pull in the gas swirling around it, mostly hydrogen and helium, the lightest and most abundant elements in the universe. Like a sponge dipped into the atmosphere of the early solar system, it absorbed everything it could. Over time, this growing ball of gas became the Jupiter we see today. This idea, often called the core accretion model, is elegant, logical, clean. It tells a story of cause and effect. But as it turns out, Jupiter isn't interested in our tidy narratives, because the deeper we look, the more that story begins to unravel. For one, if Jupiter began with a dense rocky core, where is it? Our best measurements suggest something very strange. That core is either missing or smeared out across a region too vast and too chaotic to fit the model. And that's where the other theory steps in, one far more dramatic. What if Jupiter didn't form like a planet at all? What if it began like a star? Imagine a separate, massive cloud of hydrogen and helium floating alone in the outskirts of the solar nursery, too small to ignite into a sun, but massive enough to collapse under its own gravity. A failed star. A world born in isolation. According to this theory, Jupiter didn't build itself, it happened. It was an accident of the cosmos, a rogue sphere of energy that eventually wandered too close to our sun and was captured by its gravitational pull, falling into orbit like a giant satellite. If this version of Jupiter's origin is true, then the consequences are stunning. It means Jupiter may never have had a solid core at all. It may not have a center. It may just be a fluid structure, a swirling, shapeless storm of metallic elements, shaped not by layers, but by flows. And this is where things become existential, because both theories, the tidy and the chaotic, lead us into deeper mystery. One suggests that planets can form through slow and steady accumulation. The other hints that some planets are born in violent collapse, captured accidents from the margins of starbirth. But here's the real twist. Either version might be wrong, or both might be partly true, because what we've seen of Jupiter doesn't fully match any prediction. Not quite. This is not a failure of science. This is science doing what it does best, walking into the dark with open eyes and admitting when the light isn't quite enough. And so we keep asking, we keep building better eyes, better instruments, better spacecraft, because what lies beneath those clouds still holds the key. Jupiter is a storm we've only just begun to map. And as we'll see in the next chapter, something extraordinary happened in the 1990s, something that tore the sky open and gave us our first taste of what Jupiter was hiding beneath that soft, swirling mask. A collision, a moment of cosmic violence, and for the first time, a glimpse of the monster's blood. Imagine standing at the edge of a cliff that isn't made of rock, but of gravity, not a drop into air, but a fall into mass, into pressure, into something that grips space itself and pulls it inward without end. Now imagine that cliff is not somewhere in deep space. It's Jupiter, because this isn't just a big planet. This is a bottomless well in the fabric of the solar system, and we're falling into it. We like to think of planets as places, landscapes, things with surfaces, horizons, weather, but Jupiter is not a place in the traditional sense. It is a gravitational phenomenon, an act of distortion, a warping of space-time in the form of a sphere. It doesn't merely sit in the solar system, it bends it. To understand Jupiter is to understand scale at war with comprehension. Its mass is so overwhelming that it weighs more than every other planet in the solar system combined. More than twice as much, in fact. You could erase Saturn, Uranus, Neptune, Earth, Venus, Mars, and Mercury, and Jupiter would barely notice. It is the final boss of mass in our cosmic neighborhood, and mass means gravity. Jupiter's pull is so intense that it drags comets out of the Kuiper belt and slingshots them into the inner solar system or swallows them whole. It shepherds moons the way a puppeteer handles strings, 4 of them as large as small planets, dozens more dancing around in icy orbits, all bound to its invisible dominance. Even the Sun, yes, even the Sun is slightly shifted by Jupiter's presence. As they orbit a common center of mass, the Sun itself wobbles ever so slightly. A star twitching, not because of anything nearby, but because of a planet orbiting 400 million miles away. That is the weight Jupiter carries. And yet, despite this overwhelming power, for most of human history, we knew almost nothing about what was inside. It was a sealed temple, one that refused to let light escape or matter emerge, until something hit it. It was the year 1994, a quiet July, and floating silently through the void was a comet called Shoemaker-Levy 9. Like most comets, it was a frozen chunk of water, rock, dust leftovers from the solar system's birth. It was not large, just a few kilometers across, but it was moving fast. Over 200,000 kilometers per hour, and it was aimed directly at Jupiter. Except, it never struck the surface, because Jupiter doesn't have one. What it did was even more dramatic. Shoemaker-Levy 9 had already been fractured by Jupiter's immense tidal forces, its gravity so overwhelming that it tore the comet into over 20 pieces before impact. It was as if Jupiter had taken its time, savoring the meal before consuming it. And then, over 6 days, piece by piece, the shattered remains of the comet plunged into the Jovian clouds. 21 separate explosions, one after another, each disappearing into the atmosphere with silent fury. No sound, just light, heat, gravity. We couldn't see the impacts directly from Earth. They were happening on the far side of the planet. It should have been a missed opportunity. But fate, in one of those impossible coincidences the universe occasionally offers, had other plans. At that precise moment, a spacecraft named Galileo, launched years earlier, traveling slowly toward Jupiter, was close enough to witness the event from the right angle. And so was Hubble, the new eye in orbit around Earth. Both were watching, and what they saw rewrote the story of Jupiter forever. Each comet fragment hit with a force equal to 300 million atomic bombs. Each one left behind a scar, a wound in the clouds that was visible for weeks. Massive black spots, like bruises on a god, plumes of material shot thousands of kilometers into the air. And for the first time, we could study the insides of Jupiter, thrown upward into its skies. Galileo flew right through the aftermath. Dust, gas, heat, particles that had been buried beneath the clouds for billions of years, now hanging like smoke in the upper atmosphere. And among that debris, scientists found something astonishing. Water, not trace amounts, not mist, but water in significant volume, lingering in the Jovian skies where none should exist. For decades, we'd imagined Jupiter as a hydrogen-helium monolith, and now, for the first time, it hinted at something wetter, stranger, and more complex. That discovery changed everything. Because water is a storyteller, its presence suggests histories of heat, chemistry, movement, collision. It leaves fingerprints. And those fingerprints suggested a deep internal structure we had only guessed at, one that didn't line up with any simple model of a clean, layered planet. And so, in response to this chance encounter between comet and God, humanity decided to go deeper. We built a new mission, a better one. We named it Juno, after the Roman goddess who could see through the clouds. It launched in 2011. It arrived in 2016. And it carried with it the ambitions of an entire species hungry to peel back the layers of a mystery we'd stared at for centuries. Because the truth was becoming clear, Jupiter wasn't just a strange place. It was a paradox, a monster hiding its bones in hydrogen, a storm with secrets in its core, and now we had permission from the sky to ask harder questions. What happens when gravity becomes so intense that even gas turns into metal? What lies at the center of something with no clear center? And how many other planets in the galaxy wear the same mask? The comet gave us a clue, a tear in the fabric, a moment of cosmic vulnerability, and behind that tear, we saw something no telescope could ever reveal, that Jupiter bleeds, that Jupiter drinks what falls into it, that Jupiter, for all its silence, responds. It is not merely large, it is active, reactive, responsive, and for a brief moment in the 1990s, it revealed its hunger. Jupiter is not what we thought, it is not what we taught, it is something older, deeper, heavier. A planet that eats gravity and still isn't full. At the edge of everything we know, there lies something we almost understand. Jupiter, too heavy to ignore, too strange to classify, and too important to dismiss as just another planet. For centuries, we categorized it simply a gas giant, a swirling sphere of hydrogen and helium, a king among planets. But the more we observed, the more that definition unraveled, because Jupiter, in all its power and mystery, behaves less like a planet and more like something else entirely. It behaves like a failed star. Let's slow that down. In the vast nursery of stars, a familiar pattern plays out. A massive cloud of gas collapses under its own gravity. The pressure builds, the temperature rises, and eventually, deep within its core, fusion ignites. That's the birth of a star. Hydrogen atoms smash together, forming helium and releasing light. A sun is born. Now here's where it gets strange. Jupiter started down the same path. It's made of the same ingredients, primarily hydrogen and helium. It collapsed from a vast cloud of gas. It gathered more and more material, its gravity growing like a slow avalanche. But it stopped just short. Jupiter never reached the critical mass needed to ignite nuclear fusion. It never became a true star. And so, it became something else, something in between. A protostar, a ghost sun, a star that almost was. Think of it this way. Jupiter is the nearest example we have of what might have happened to our sun if it had been born just a little smaller. This changes the narrative entirely, because now we're not talking about a big version of Earth. We're talking about a small version of a star, a cold, dense, unlit flame drifting through space, still heavy with the potential it never realized. And in this light, its behavior starts to make more sense. Jupiter emits more heat than it receives from the Sunday. It glows faintly from within. That's not planetary behavior. That's leftover energy from a formation process, so intense it still radiates 5 billion years later. Its immense gravity doesn't just hold on to moons, it shapes entire belts of asteroids, warps the orbits of comets, and stabilizes the very architecture of the solar system. Even our Earth may owe its stability to Jupiter's pull, and yet, despite all this dominance, it remains in the shadows, a heavyweight that never entered the ring. Which brings us to the great paradox. How did Jupiter form? The leading theory, the one in the textbooks, goes like this. A rocky core, maybe 10 times the mass of Earth, slowly accumulated material in the early solar system. Once it got big enough, it began pulling in hydrogen and helium from the surrounding protoplanetary disk, ballooning into the giant we see today. This theory is known as core accretion. It's neat, it's tidy, it fits the formation of other planets. It's a story of gradual growth, gravity doing its quiet work over millions of years. But there's a problem. When we probe Jupiter, when we actually look inside, we don't find a clear, dense core. We don't find a sharp transition from rock to gas. Instead, we find something fuzzy, mixed, chaotic, like a soup that never settled. That core accretion model predicted a stone heart wrapped in gas. What we find is more like a storm that never ends, a blur between phases, a memory of collapse, smeared across tens of thousands of kilometers. Which leads us to the other theory, gravitational instability. This version suggests that Jupiter didn't start with a solid core at all. Instead, it began as a massive clump of gas, maybe sitting on the edge of the solar system or even beyond it waiting. Then, in a moment of instability, it collapsed, rapidly, violently, and as it did, it formed into a self-contained ball of gas and metal, something much closer to a brown dwarf star than a terrestrial planet. Under this scenario, Jupiter didn't grow into its shape, it fell into it. It wasn't built, it was born. There's something poetic here. Two theories, one of gradual construction, one of sudden collapse, one a mirror of Earth's formation, the other a mirror of stellar birth. And somewhere in the data, between the cloud layers and gravitational waves, is the answer. But we don't know it yet. And that's the most humbling truth of all. Even with decades of observation, flybys, impact events, and space probes, we still don't know how Jupiter came to be. What we do know is this: whatever path it followed, Jupiter almost became something else. It is a star that failed but not entirely, a gravitational monarch that missed its crown of fire, a lesson that formation does not always mean fulfillment. And maybe, just maybe, that story is a reflection of something deeper. In nature, not all growth leads to light, not all collapse ends in destruction. Some things are born into in-between states. Some objects remain powerful, even without ignition. Some forces shape everything around them, while remaining dark at the center. Jupiter is a monument to potential, a relic of another path the universe might have taken, a second sun that never caught fire. And it leaves us with a haunting question. What if Jupiter had become a star? What if our solar system had two suns, our sky split between day and brighter day, Earth scorched by twin sources of light? What if the world we know exists only because Jupiter didn't become what it almost was? In the silence of space, Jupiter keeps that answer to itself. And yet, in its storms, in its swirling belts of gas and liquid metal, in its pull on comets and moons and time itself, it whispers. Not every fire needs to burn to leave a mark. Sometimes the universe opens its hand and lets us see something it never meant to show. It was July 1994. Earth was spinning as usual. Radios hummed with summer songs. The internet was still a novelty. Most people were not watching Jupiter, but out there, beyond the asteroid belt, something extraordinary was unfolding, a once-in-6,000-year event, and we were about to witness it. A comet was falling toward a planet with no ground. It was called Shoemaker-Levy 9, a fractured string of icy debris, each piece a few kilometers across, spiraling like beads on a broken necklace, frozen relics of the solar system's birth, and they were all headed directly for Jupiter. Now here's what makes this moment mythic. The collision itself was astonishing, but what framed it, what made it almost feel scripted by something beyond chance, was timing. The Hubble Space Telescope had just come online. The Galileo spacecraft, launched in 1989, was approaching Jupiter and had a direct line of sight to the impact. Two eyes, one in orbit, one en route, both ready, both waiting, as if the universe had arranged its instruments just so we wouldn't miss it. And then, over 6 days, it happened. 21 separate impacts. Each fragment of the shattered comet plunged into Jupiter's thick cloud layers at over 200,000 kilometers per hour. Each one disappeared into the atmosphere, not with a crash, but with a flash. A flash we couldn't hear. A flash that could have swallowed entire cities in a blink. The largest of these impacts released more energy than 300 million nuclear bombs. And yet, not a sound. Only the ghostly bloom of fire under clouds. Only the aftermath. When Jupiter rotated and revealed its face to Earth again, we saw the scars. Immense, dark circles, black as ash, wide as continents stained across its atmosphere. Wounds that lingered for months. Proof that something ancient and vast could still be hurt. Galileo, approaching through the vacuum, flew through the debris. For the first time, we had a probe inside the storm. Instruments tasted the chemicals, read the temperature, mapped the fallout, and something unexpected appeared in the data. Water, deep inside Jupiter's atmosphere. Scientists found signatures of water in quantities that shocked them. The upper clouds had always seemed dry, formed of ammonia and hydrogen. But here was a different signature, one we could not explain away. It raised a tantalizing question. Was this water from the comet, or from Jupiter itself? If the former, it told us how comets might have seeded water across the solar system, even Earth. If the latter, it meant Jupiter was hiding reservoirs of water deep within water that had never before touched sunlight, now drawn up by the violence of impact. That moment, for science, was like the planet opening its mouth mid-breath. For a flash, we saw its insides. But the story isn't just scientific. There's something existential in what happened. We always imagined Jupiter as a protector, a massive shield at the edge of the inner planets, a gravitational sponge that catches comets and saves us from doom. And in some sense, it is. Shoemaker Levy 9 might have struck Earth in a different timeline. Jupiter pulled it away, took the hit, swallowed the chaos. But there's something deeper here. We often look up at Jupiter as if it's a distant, stable god. But this event reminded us it is mortal in its own way. It can be wounded, it can be changed. Its scars, though made of vapor and cloud, are no less real. And those scars revealed something almost too large to comprehend. That the planet is not just a gas giant, it's a vessel of hidden truths, a place that holds within it the history of the solar system, compressed and spinning. Shoemaker Levy 9 was not just a comet, it was a key, and Jupiter, for just a moment, unlocked itself. That's how science advances sometimes, not with certainty, but with impact, with collision, with forces so great they leave marks no theory can ignore. The aftermath of that comet sparked decades of questions. Missions were altered, models revised. It made us ask, more seriously than ever before, what is Jupiter? And more hauntingly, what is it hiding? Because now we knew that what we thought we understood, that Jupiter was simply a ball of gas, was far from the truth. Beneath its clouds, there was depth, structure, heat, water, and something else. The comet had cracked the sky open, but we needed more than a glimpse. We needed a descent. We needed to fall into the giant's heart. And so we built a spacecraft for that purpose alone. Its name was Juno, and it would go further than Galileo. It would orbit close, map the magnetic fields, scan the gravity, and try to answer the question that Shoemaker Levy 9 had asked with its death. What lies beneath? But that's for the next chapter. For now, let's pause and look back at the comet not as debris, not as accident, but as messenger. Shoemaker Levy 9 was born from the solar system's cold edges. It wandered for eons, and then, in one of the rarest alignments imaginable, it fell into a planet no one had ever touched, and by doing so, it revealed the secrets that clouds had hidden for billions of years. It took destruction to bring clarity. It took death to bring understanding. That's the paradox of cosmic knowledge. Sometimes, to learn what something is, you have to break it. And Jupiter, in all its power, let itself be broken just enough to show us what it truly is. A world that bleeds water, a storm that swallows comets, a god that remembers pain, and that pain became the beginning of a new kind of vision. The sky is not empty. It is layered, structured, and full of secrets. When we look at Jupiter, we see color and motion, but that's just the surface and illusion of simplicity. In truth, Jupiter is a cathedral of clouds, storms, and chemistry, stacked in columns of unimaginable height. And somewhere inside that cathedral, it rains, but not as it does on Earth. It rains slush, it rains ammonia, it rains liquid that has never touched land. And now, thanks to the comet and the spacecraft that followed, it was time to explore the cathedral from the inside. When the Galileo probe arrived at Jupiter in late 1995, it did more than observe. It dove. For the first time, a machine built by human hands pierced the outer veil of a gas giant and sent back whispers from within. The probe didn't last long. Jupiter's atmosphere is not kind. Within minutes, the pressure became overwhelming. Within hours, Galileo was gone, crushed, melted, erased. But before it disappeared, it sent back data. Vital, electric, beautiful data. And in that short transmission, something leapt out. Water, not in trace amounts, not as vapor clinging to cold hydrogen, but as a presence, a force, liquid water, deep, moving, violent. The reaction in the scientific community was confusion, then disbelief, then awe, because according to the old models, water shouldn't have been there, not like this, not that deep, and not that active. Water is heavy compared to hydrogen and helium. It tends to sink. Yet here it was, rising, mixed into storms, electrified, alive. This water wasn't behaving like an afterthought. It was doing something. That discovery set a new course. If there was more water below the clouds hidden, pressurized, moving, it meant that Jupiter was not a simple gas ball with a rocky core. It meant Jupiter had structure, depth, process. It meant Jupiter had weather that extended thousands of kilometers down. And so, scientists began dreaming bigger. What if we built a mission to track that water, to trace its heat, to map the gravity and magnetic fields that told us how deep the layers go? That mission became Juno, launched in 2011, arrived in 2016, a probe named for the Roman goddess who could see through clouds. How perfect is that? Juno's orbit was polar, sweeping over the planet's poles in long, looping arcs, diving in and pulling away again, like a pendulum of curiosity. With each pass, it mapped more, saw deeper, felt the curves of gravity as if blindfolded, touching the surface not with eyes, but with mathematics. And with every sweep, the story of Jupiter got stranger. Let's start at the top. Jupiter's highest clouds, what we see from Earth, are made mostly of ammonia ice. This is not like anything you breathe. Ammonia is toxic, volatile, and when mixed with water in the cold upper atmosphere, it creates a kind of antifreeze. That antifreeze allows for the existence of liquid water even at temperatures below minus 100 degrees Celsius. As those droplets and ice crystals mix, they begin to separate by density. Some freeze, some melt, some rise again. And when they collide, something magical happens. Static charge builds. Electricity flows. Lightning is born not in clouds like Earth's, but in towers of storm hundreds of kilometers high. We used to think lightning only happened near the equator. Juno proved otherwise. Jupiter's poles are filled with lightning too, bursts of light in darkness, dancing across the planet's crown like auroras in a dream. These polar storms aren't random. They're organized, geometric. Cyclones arranged in perfect shapes, hexagons, pentagons, like the petals of a flower, too large to comprehend. Imagine that. A flower made of storms. A geometry written in gas and fire. Deeper still, those storm cells become rivers. Rain falls, not water rain, but slush, ice, ammonia, liquid methane. Each drop falls for hundreds of kilometers before it hits a layer hot enough to vaporize it again. And up it goes. A cycle without end. A planet inhaling and exhaling storms. And through it all, threaded like a pulse, there is water. Water is not passive here. It's not a quiet lake. It is turbulent, active, dragged by convection, shaped by magnetism. In Jupiter, water is a force of structure, a player in the planet's evolution. It carries heat. It defines density. It whispers secrets about how the planet formed. And that whisper says Jupiter is old, very old, older than Earth, maybe the first thing to take form after the Sunday. Which raises an ancient question. Did Jupiter's water come from the same place as Earth's? We've always wondered where Earth got its oceans. Some say they came from inside, leaking out through volcanic breath. Others say they came from space, from icy comets crashing into a young planet. But if Jupiter had water too, a lot of it, then maybe the real answer is more profound. Maybe water was always there, in the beginning, as old as hydrogen itself, and maybe Jupiter is the guardian of that original water, hidden, preserved, pressurized into memory. This turns the planet from a curiosity into a museum, a place where the oldest molecules still exist, unaltered by rock or sunlight or biology. Jupiter becomes a record keeper not of civilization, but of matter. So when Galileo saw water in the comet's wake, and when Juno mapped it deeper still, We weren't just learning about a planet, we were learning about beginnings, about the chemistry that makes life possible, about the forces that shaped the early solar system, about the weather of the gods, and in this cathedral of storms and slush, water sings a hymn of time. It falls, it rises, it sparks, it flows without ever touching ground. No rivers, no lakes, just currents of sky within sky within sky. And so we come to the edge of another mystery. If water exists in Jupiter, deep, old, and alive, what else might exist there? Could life ever emerge in such a place? Or is Jupiter simply a furnace of potential, a world that mixes life's ingredients, but never lets them settle? No one knows. Not yet, but we do know this. When the comet struck and the sky fell into itself, Jupiter bled water, and the universe finally let us taste the rain. There is a place where maps become useless, where depth is not a measurement, but a mystery. That place is Jupiter. And if we are honest, for most of history, we only ever knew its surface lies. Stripes, clouds, a swirl of color and chaos. But with the arrival of the Juno spacecraft, we began peeling back the layers of illusion. We started asking not what Jupiter looks like, but what it is. And the answers came, not all at once, but like pressure waves, slow, heavy, building, because Jupiter is a giant with layers, layers of clouds, layers of pressure, layers of identity. And with Juno, we discovered that most of what we thought we knew was wrong. Let's start with the first betrayal, the clouds. From Earth, Jupiter looks thick, dense, impenetrable. We see bands of color, tan, white, orange, red. These are massive cloud systems, stretched by the planet's rapid rotation into permanent jet streams. Some blow east, some west. They move at hundreds of kilometers per hour, trapped in loops that never end. Beautiful, hypnotic, but thin, very thin. Despite their grandeur, the depth of Jupiter's visible clouds is only about 50 kilometers. That's it, 50. You could stack 6 Mount Everests and still not reach the bottom. Beyond that, the gas grows heavy, hot, and strange. Beneath the colors, the planet begins to change. You see, heat on Jupiter doesn't come from the Sunday sunlight, is almost an afterthought here. Jupiter is too far away. The real heat comes from the inside born from the planet's original collapse, from gravity squeezing matter inward, crushing atoms until they protest by vibrating harder and faster. This is internal heat, ancient heat, and it fuels storms not from above, like on Earth, but from below. Imagine that. Weather that starts from the center of a planet, not its atmosphere. The heat rises, it lifts plumes of gas, it stirs the clouds. It creates the Great Red Spot and hundreds of other vortices, each a storm larger than Earth itself. Lightning bursts in silence. Ammonia rains melt and reform in endless cycles. The sky becomes an ocean with no floor, but this ocean is not made of water. It's made of hydrogen. And this is where things get truly strange. Because hydrogen, the lightest element in the universe, is not supposed to behave like this. Under normal conditions, hydrogen is a gas. It's what fills weather balloons or fuels the Sunday. It's elusive, gentle. But under the crushing gravity of Jupiter, it transforms first into a dense fog, then into a liquid, and then into something that defies experience, a metal. Yes, Jupiter makes metal out of hydrogen. This is not science fiction. This is the consequence of pressure. At a depth of about 1,000 kilometers below the clouds, hydrogen gas transitions into liquid hydrogen. This is the closest thing Jupiter has to a surface, a sea of hydrogen. The largest ocean in the solar system, thousands of kilometers deep, with no land, no coast, no horizon, just pressure increasing forever downward. But the journey doesn't stop there. Keep falling, keep descending, and the pressure builds until something impossible happens. The hydrogen breaks. Its electrons are torn away from their atoms. It becomes electrically conductive. It becomes metallic, not like steel, not like iron, but liquid metal, flowing, reflective, alive with charge. Metallic hydrogen is a theoretical material we can barely create on Earth. In the lab, it lasts nanoseconds. But in Jupiter, it is an entire inner world, a metallic ocean 30,000 kilometers deep, circulating with the planet's spin, generating electric fields, fueling magnetism. This is how Jupiter's magnetic field becomes so immense. It's not just a planet, it's a dynamo, a spinning, churning conductor of liquid metal, producing a magnetic field 14 times stronger than Earth's, and so large it stretches millions of kilometers into space. Jupiter's magnetic field is a monster. It traps particles. It deflects solar wind. It creates radiation belts, so intense they would fry an unshielded spacecraft in minutes. Even Juno, hardened as it is, must hide. It flies in careful loops, dipping in and out of the radiation zones, like a thief avoiding searchlights. But the rewards are worth it. With each orbit, Juno maps the gravity and magnetism in greater detail, and as it does, the image of Jupiter's interior grows sharper and stranger. We once imagined Jupiter as a layered cake: atmosphere, liquid hydrogen, metallic hydrogen, and then a solid core. But the data tells a different story. There are no clean layers, no sharp boundaries. Instead, there is blending, gradients, regions where one state of matter dissolves into another. The line between liquid and metal is smeared. The transition from gas to liquid is foggy. And at the center, where we expected a solid core of rock and iron, we find something else. We find fuzz. The term scientists use is a fuzzy core. It's not a neat ball of metal. It's a vast region, maybe half the planet's radius, where rock, metal, and hydrogen are all mixed together in a soup, a gravitational blur, a chaos of elements that never resolved into order. This is a kind of planetary uncertainty, and it's deeply humbling, because it tells us that not all planets are simple spheres with clear interiors. Some are storms all the way down. Some are laboratories of pressure and fusion and magnetic alchemy. Some are lies we told ourselves until better data arrived. Juno didn't just uncover new facts. It uncovered a new idea of what a planet could be. Jupiter is not solid, not structured, not still. It is a liquid within a liquid, a storm within a field, a fusion of elements without end. And we are only beginning to understand it. So we keep listening. As Juno loops above the poles, it sends whispers, readings, fields, signals, and every one of them chips away at the idea that we knew what we were looking at. Because we didn't, we only saw layers, and the truth was always hiding in between them. It's not just a storm. That's what we were told for decades. That the great red spot on Jupiter was a swirling weather system, a super hurricane, a vast spinning vortex larger than Earth. And yes, it is all of those things. But that's not what it means, because this thing, it's been there for at least 400 years, maybe longer, before steam engines, before telescopes were widespread, before electricity crackled through human hands. This storm was already raging, and it still hasn't stopped. Ask yourself, what kind of force burns for 4 centuries without fading? What kind of planet can host a storm so massive, so deep, so ancient, that it becomes part of the landscape except there is no landscape? Let's start with the facts. The Great Red Spot is roughly 16,000 kilometers across. That's about twice the diameter of Earth. It spins counterclockwise, completing a full rotation every 6 days. Its winds howl at speeds up to 400 kilometers per hour. But here's the twist. It's shrinking. For the last 100 years, the storm has been getting smaller, tighter, more intense. No one knows why. No one knows if it will disappear or erupt. It's alive, evolving, and no simulation yet can fully predict its future. We used to think of the Great Red Spot as a surface phenomenon, just another swirling system like a hurricane or typhoon. But Juno shattered that illusion. The spacecraft revealed that this isn't just a skin-deep wound in the clouds. The red spot reaches hundreds of kilometers downward. It is deep. It's a column of motion that extends through multiple layers of Jupiter's atmosphere, through ammonia clouds, water clouds, and into the slushy, high-pressure world below. It's not a storm like we know storms. It's more like a mountain made of motion, a spinning pillar of kinetic energy that burns from the inside. And at the top of that pillar, something even stranger happens. The uppermost edge of the great red spot stands higher than the surrounding clouds. It sits like a dome, lifted by its own convection, and because it's elevated, it absorbs more ultraviolet radiation from the sunday. That radiation triggers chemical reactions between sunlight and trace gases, ammonia, acetylene, and others. The result? The red. We don't actually know what exact chemicals create the crimson hue. That remains a mystery. But we know it's a response to light, a reaction, a symptom of its height. The storm isn't just deep, it's tall, so tall that it changes color in response to space itself. Imagine that. A weather system that's not just moving, it's climbing. But it gets stranger. Within the Great Red Spot, temperatures are higher than anywhere else in the atmosphere. The pressure is more intense, and the storm seems to resist disruption. Smaller storms get pulled in and absorbed. It feeds on turbulence. It grows from chaos. It's not decaying, it's evolving. It's almost alive. Not in a biological sense, but in the way a star is alive, in the way fusion lives. The Great Red Spot is sustained by energy gradients, motion, heat, and imbalance. It is a system that endures not by stability, but by imbalance maintained perfectly over time. It exists because things are wrong, and that's the paradox. The very instability of Jupiter's atmosphere is what gives rise to something so eternal. On Earth, storms dissipate when energy is exhausted. On Jupiter, energy is abundant. The internal heat keeps rising. The rotation stays fast, one full spin every 10 hours. That rapid spin creates strong Coriolis forces, which keep storms like the red spot locked into semi-permanent bands of latitude. It's trapped, not by force, but by motion, locked into its lane, forever spinning. We think of Jupiter's surface as fluid, without ground, but in this storm, we see the opposite, something anchored, something that won't go away. And this brings us to the deeper meaning. The Great Red Spot is not just a meteorological curiosity. It's a symbol, a window, a message from the planet itself. It tells us that time is not the same everywhere, that some processes can last far longer than we're used to, that our human perspective, weeks, years, lifetimes, is too short to comprehend certain systems. We call it a storm because we lack a better word. But what if it's something more? What if it's a memory? A remnant from the planet's formation, a wound that never closed, a scar that bleeds wind and pressure instead of blood, or perhaps a ritual Jupiter's eternal performance, playing out in cycles that dwarf history. What we're seeing in the Great Red Spot may not be a temporary system, it may be a feature, a necessity of Jupiter's energy balance. Remove it, and the planet might shift, spin differently, sing a new song. That's how foundational it might be. And here's another layer to consider. There are other spots, other storms. The planet is covered in ovals, belts, vortices, cyclones. At the poles, Juno discovered perfectly symmetrical storms, arranged in geometric constellations, pentagons in the north, hexagons in the south. It's as if the planet is writing a language in its clouds, one we haven't yet learned to read, a language of motion, of heat, of imbalance perfected. So perhaps the Great Red Spot is not alone. Perhaps it's the eye in a greater pattern, a signpost of deeper forces. And this makes us wonder, if Jupiter can host storms the size of worlds, lasting centuries, what might we find on gas giants beyond our solar system? What kind of cosmic weather rages in the atmospheres of super-Jupiters, orbiting distant stars? Could there be red spots, larger than Earth, older than human civilization, burning quietly in the night? Jupiter shows us what's possible. A storm that stands taller than Everest, reaches deeper than the ocean, and spins with the fury of a planet's breath. A storm that doesn't pass but remains. We call it the red spot, but perhaps it should be called what it truly is: an altar built by gravity, sustained by motion, painted by light. And if you listen closely, it whispers, "I am not a storm. I am what storms dream of becoming." What happens when you fall into a planet that never ends? Imagine the descent through clouds that rage and churn, through storms that have outlived civilizations, through hail made of ammonia and skies that bleed water. The light fades, the colors blur, pressure rises like an invisible fist, squeezing tighter with every kilometer. And then something impossible happens. The gas turns to liquid. We are not built to think of gas becoming liquid without cold. On Earth, when steam condenses, it cools into water. But Jupiter doesn't follow Earth's rules. On Jupiter, it's not cold that turns the fog into fluid, it's gravity. Let that sink in. Jupiter is so massive, so gravitationally dominant, that it compresses hydrogen, the lightest, most elusive element in the universe, into liquid. Not with cold, but with sheer weight. With crushing, relentless pressure that pushes down so hard, molecules surrender their freedom. At around 1,000 kilometers beneath the visible clouds, you pass through the threshold. The hydrogen gas becomes so tightly packed that it transitions smoothly, eerily, into a liquid state. There's no hard surface, no floor, just a gradual thickening of matter, a blur between sky and sea, a place where physics doesn't stop, it shifts. And this ocean? It's unlike anything on Earth. It is the largest ocean in the solar system. Not of water, not of salt, an ocean of liquid hydrogen. You could drop all of Earth's oceans into it, and they'd vanish like raindrops. This hydrogen sea stretches for tens of thousands of kilometers in every direction, completely encasing the core, sloshing in silence beneath the cloud bands, conducting the will of the planet like a heartbeat beneath skin. And unlike water, this ocean doesn't shimmer, it doesn't wave. It flows in ways we barely understand, tides moved not by moons, but by magnetism and inertia. Now, keep falling. As you sink deeper into this alien sea, the pressure grows not linearly but exponentially. Every additional kilometer increases the weight above you by factors beyond intuition. The temperature begins to soar. 100 degrees, 1,000, several thousand, and still, hydrogen remains a liquid. Why? Because pressure changes the rules. On Earth, we liquefy hydrogen by cooling it to below minus 250 degrees Celsius. But Jupiter does the opposite. It keeps the hydrogen hot over 1,000 degrees and instead forces it into a liquid by crushing it with the weight of the atmosphere above. We're in unfamiliar territory now. This is not chemistry as we know it. This is atomic coercion. Matter reshaped not by temperature, but by pressure, gravity, and time. And deeper still, things begin to glow, not with visible light, but with energy, with movement. At these depths, electrons in hydrogen atoms begin to break free. The bonds that define normal matter atoms, with obedient electrons spinning around their nuclei, begin to loosen. Hydrogen, under this pressure, begins to behave more like a metal than a gas. This is where we cross the next threshold, into the metallic zone. Here, hydrogen becomes metallic hydrogen, still a liquid, but now it can conduct electricity. It flows, but also hums with charge. It pulses with current. It becomes a sea of free electrons, like mercury made of stars. This is not a fantasy. This is not speculation. This is what Juno confirmed, a vast interior, not just of fluid, but of metallic fluid, the beating, flickering, metallic heart of a planet. And it changes everything. Because this liquid metal ocean is what generates Jupiter's massive magnetic field. It spins with the planet. It moves with the rotation. It acts like a planetary dynamo, creating currents that radiate outward and shape the space around the planet. Jupiter's magnetosphere is enormous, so vast that if you could see it with the naked eye, it would be the largest object in the night sky, larger than the moon, larger than the sun. This magnetic field traps radiation, bends charged particles, shapes the auroras at Jupiter's poles, which are so powerful they would strip the atmosphere from a lesser world. It shields its moons. It deflects solar wind. It hums like an electric drum in the vacuum of space. And all of it comes from hydrogen behaving badly, from fog turning to fire, from gas becoming liquid, and liquid becoming metal. This is where Jupiter stops being a planet and starts being a process, a machine, a pressure engine that turns gravity into structure, a furnace that converts raw mass into energy fields. And it all comes back to a simple fact. Jupiter is heavy, heavier than the mind wants to grasp. And that weight, that mass, isn't just sitting there, it's doing something, pressing down, heating up, transforming reality molecule by molecule, layer by layer. And as we descend, it gets harder to say where matter ends and energy begins. Because beneath the metallic hydrogen layer, deeper still, lies a region we can't yet model, not accurately. We think it may be a mixture of rock, ice, and metals. But the boundaries are blurry, fuzzy. There may be no clear surface at all, just more gradients, more transitions, more uncertainty. This descent into Jupiter is not like falling into Earth or Mars. It's not a journey from sky to surface. It's a journey from familiar to alien, from matter to mystery. Jupiter is not made of layers. Jupiter is a layer, a gradient, a transition from one state of reality to another. We call it a planet, but it's more like an event, a transformation that never stops, wrapped in clouds and spinning through space. And here's the truth most textbooks miss. You can't land on Jupiter. There's no place to stop, no place to rest, no solid ground, only falling, forever falling, deeper and deeper into heat, pressure, metallic hydrogen, and then we don't know, and maybe that's what Jupiter really is. Not a place, but a path, a way down, a reminder that even in the familiar, the fifth planet from the sun, there are depths so strange, so violent, so profound, that they redefine what we mean by planet. The fog turns to fire, the gas becomes sea, the sea becomes metal, and beyond that, the story continues. What if you dove so deep into a planet that even light forgot how to reach you? Beneath Jupiter's clouds, below the painted storms and icy ammonia rain, there is a silence so complete, it might as well be myth. You are falling through hydrogen, yes, but not the kind you've ever known. You are descending through a medium more like memory than matter. And now, at this unthinkable depth, you reach a place where the rules begin to change. Here, hydrogen becomes metal, and metal flows. This is not solid metal like the steel of a spaceship or the copper in a wire. This is liquid metal hydrogen forced into a strange new identity by a gravitational crucible. Under pressures millions of times stronger than Earth's surface and temperatures that reach beyond 10,000 degrees Celsius, the atoms that once made hydrogen a gentle gas are violently reshaped. Their electrons are stripped away not by fusion, but by force. And what's left behind is a churning ocean of positively charged nuclei, swimming through a sea of free-floating electrons. This is metallic hydrogen. It is not an idea. It is not a theory. It is a sea that conducts lightning. Imagine a fluid that behaves like a wire, that pulses with electric current, not just on its surface, but through its depth, that flows with a rhythm that syncs with the rotation of an entire planet, that spins like a dynamo, turning kinetic motion into magnetic force on a planetary scale. This is the machine inside Jupiter. It is not powered by fire, but by pressure, not built of gears, but of fields. And it generates a magnetic aura so powerful, it extends millions of kilometers into space. Jupiter's magnetosphere is the largest structure in the solar system, larger than the Sunday. If you could see it with your eyes, it would dominate the sky. This field is not just a shield, it is an influence. It bends the paths of particles, captures radiation, sculpts the solar wind. It traps electrons and protons in belts so deadly they would annihilate an unshielded astronaut in seconds. It lights up the poles with auroras far more powerful than Earth's, glowing in ultraviolet and X-ray bands. It makes the invisible burn. All of this from a sea of metal beneath a layer of clouds. Let that sink in. We call Jupiter a gas giant, but inside, it's a metal ocean, a thunderous conductor, a place where lightning is born not from friction, but from structure, the kind of lightning that doesn't flash, it flows. This metallic hydrogen doesn't sit still. It circulates. It rises and falls in convective currents, just like water in a boiling pot. But here, the pot is 40,000 kilometers deep, and the boiling drives a magnetic engine large enough to hold moons in its grip. And it's not just the field that moves. Gravity waves ripple through this fluid, tides of density roll and crash. You could ride them for days and still not reach the center. And what lies at the center? That question haunted scientists for centuries. We assumed, for so long, that a massive world like Jupiter must have a solid heart, a core of iron and rock, something dense and permanent around which the rest of the planet formed. But what we've found instead is something far more mysterious: the fuzzy core. Yes, that's the actual scientific term, because instead of a crisp, well-defined boundary between core and liquid metal, Juno discovered a vast, ill-defined region, half the radius of the planet, where heavy elements, rock, metal, and hydrogen are all mixed together. No shell, no structure, just a churning, chaotic mass of ingredients that never settled into neat layers. It's like stirring molten lead into soup and watching the whole pot vibrate with contradiction. This fuzzy core changes everything. It means Jupiter may not have formed the way we thought. If the core is not distinct, then perhaps it was disrupted, smeared out by a massive collision early in its life. Perhaps Jupiter consumed another protoplanet, 10 times the size of Earth, and in the process, its core was diluted, fractured, and mixed into the metallic sea. That idea that Jupiter is a survivor of cosmic violence reframes it once again, not just as a failed star, not just as a machine, but as a wounded god, a being shaped by an ancient trauma, still holding its shattered heart inside. And that heart pulses, because all this movement, all this chaos, still follows rhythms. There are patterns in the fields. Juno has mapped magnetic anomalies, regions where the field wobbles or spikes. We've found zones where charged particles spiral in strange loops, tracing out unseen currents deep within the metal ocean. Jupiter is not still. It hums, it thrums, it sings, in frequencies we cannot hear, but that we can measure, in radio waves, in plasma waves, in pulses of radiation that beat in time with the rotation of the planet. This is a planet that speaks in fields, and as those fields extend outward, they affect more than space. They shape the behavior of moons. Io, the volcanic moon closest to Jupiter, is caught in this web. It bleeds ions into Jupiter's magnetosphere, creating an electric current between itself and the planet, a literal electrical circuit between a moon and its master. Auroras bloom at the magnetic footprints where the field touches atmosphere. Jupiter is not just a planet. It is an electromagnetic empire. It commands its surroundings with unseen hands. It sculpts plasma. It generates storms not just in weather but in particles. And all of it, from a sea of metallic hydrogen, created by pressure, moved by spin, and deep enough to drown Earth 100 times over. So next time you look at Jupiter, remember this. You're not just looking at clouds. You're looking at a conductor the size of a world, a sea of metal hidden beneath storms, a liquid lightning engine that hums through the dark. And the deeper you go, the louder it sings. The deeper you go, the less clear things become. At the top of Jupiter, everything feels sharp. Jet streams, storm bands, geometry etched in cloud. But in the depths where pressure smothers definition and temperature melts boundaries, the lines begin to blur. And at the very center of it all, where gravity is greatest and the weight of the solar system collapses inward, we find not a core, but a contradiction. For centuries, we imagined Jupiter's heart as solid, dense, heavy, with iron and rock, a firm foundation around which the gas and metal and storms were built. After all, if Jupiter was formed by accretion, a seed of rock that pulled gas toward itself over millions of years, then surely, at the bottom of it all, there must be something solid left. That was the model, the logic, the narrative. But when Juno arrived and began listening not just to the surface, but to the subtle tugs and waves of Jupiter's gravitational field, It discovered something no one expected. The core was not solid. It was not even separate. Instead, it was smeared out, diffuse, chaotic, expanding tens of thousands of kilometers across. A vast, roiling soup of rock, metal, hydrogen, and other elements all stirred together. A molten memory of something that once might have been a core, but was now more like a half-dissolved ghost. This is what scientists now call the fuzzy core. It's not just a poetic term, it's a technical diagnosis. The center of Jupiter has no distinct edge, no surface, no hard boundary between where the metallic hydrogen ends and the heavy elements begin. The transition is gradual, a bleed, a soup instead of a stone. Imagine diving to the bottom of the deepest ocean, and instead of hitting seabed, you find more water, thicker, heavier, denser, until even the idea of bottom begins to collapse. That's what the core of Jupiter feels like, and it raises uncomfortable questions. If Jupiter's core is fuzzy, then maybe it was never solid to begin with. Or maybe it was, but something shattered it. Something ancient, violent. One theory suggests that, in the early days of the solar system, Jupiter collided with another massive protoplanet, perhaps 10 times the mass of Earth. The impact wouldn't have destroyed Jupiter. It's too big, but it might have disrupted its internal structure, dissolving the core into the overlying metallic hydrogen, mixing rock and metal like cream into coffee. That collision would have left behind the planetary equivalent of trauma, a scar, not on the surface, but in the soul. And that scar is still there, still swirling, still undecided, still fuzzy. But what if there was no impact? What if the fuzziness is not the result of violence, but of process? What if gas giants, especially the largest ones, never develop clean cores at all? After all, Saturn, Uranus, Neptune, we haven't sent orbiters there with the same precision as Juno. For all we know, they too might be fuzzy inside, their hearts unclear, their identities uncertain. Maybe Jupiter is not the exception. Maybe it's the prototype. If that's true, then the idea of a planet having a neat, spherical core may be more Earth-like bias than cosmic truth. We like boundaries. We crave structure. We want to know where something begins and ends. But Jupiter refuses to be categorized. Its very essence dissolves those categories. And that dissolution isn't just physical, it's conceptual. Because a fuzzy core challenges the way we think about formation, growth, stability. It tells us that the center does not always hold, that mass doesn't always condense into order, that sometimes the middle is the most uncertain part. And maybe that's not a flaw. Maybe it's a feature. Because Jupiter still exists, still spins, still holds together. It functions, not in spite of its fuzziness, but because of it. Perhaps a chaotic interior gives the planet more resilience, more ways to redistribute heat, pressure, momentum. Perhaps the absence of a solid center allows Jupiter to adapt, evolve, survive impacts that would shatter smaller worlds. It makes you wonder, could fuzziness be a kind of strength? Could vagueness, in the right context, be stability? Could the most powerful object in the solar system, second only to the sun itself, be built not on certainty, but on blur? That idea is almost existential. It mirrors something inside us. We search for a core within ourselves, a clear identity, a solid center. But often, what we find is layered, shifting, paradoxical. Not a sphere, but a soup. Not a line, but a gradient. And Jupiter, in its vastness, may simply be showing us that this is okay, that a heart can be real, even if it's undefined, that a world can be whole, even if it lacks a sharp core. The fuzzy core is not failure, it is complexity. It is becoming, not completion. And so, Jupiter becomes a mirror again, not just of physical processes, but of the philosophical ones, of growth, of ambiguity, of structure born not from clarity, but from the dance of opposing forces. Because deep inside that churning metallic sea, there is still gravity, there is still shape, there is still a center, even if we can't draw a line around it, even if it refuses to be pinned down. Jupiter is not just a gas giant, it is a cathedral of pressure, light, and transformation. And at the very heart of that cathedral, where the walls dissolve and the floor becomes sky again, lies a truth far more profound than rock. That sometimes the strongest center is the one that moves. Even now, after centuries of watching and decades of flying spacecraft into its orbit, Jupiter remains unsolved. We have stared at its clouds, mapped its magnetosphere, plunged probes into its storms, and still, the questions run deeper than the data. Because the further we descend into this world of pressure and motion, the less we find answers and the more we uncover the impossible. This is how mystery defends itself. One final question lingers at the end of our descent. How did Jupiter become what it is? We know the models, we've heard the theories, that it formed like Earth, slowly growing a rocky core, then pulling gas around it, or that it was born differently, collapsing like a failed star, too light to ignite, too heavy to ignore. But as with so much of Jupiter, the evidence blurs. We used to be certain about the core, solid, dense, planet-like, but we now know it's fuzzy, smeared across half the radius of the planet. We thought the layers were distinct, clean, ordered. We found instead a deep storm, a gradient of states, a sea of metal, a sky without ceiling or floor. And so scientists turned to the only tool left, simulation. If we cannot directly observe Jupiter's birth, we can try to recreate it. We build digital models, mathematical laboratories that run faster than time itself. We simulate collisions, dozens, hundreds, thousands. We throw planets the size of Earth, 10 times Earth, into a young, molten Jupiter and watch what happens. And what happens is astonishing. Every time, the result is the same. The impact disrupts the core. It turns a compact planet into a fuzzy mess. The core dissolves upward into the metallic hydrogen, exactly like we see today. The violence is immense. It scatters elements throughout the planet. It reshapes the very nature of what Jupiter is. But then something strange. In every simulation, over time, the chaos settles. The fuzziness retracts. The core reforms. The heavy elements sink back down. Order returns. A solid core reappears. Yet this has not happened on Jupiter. The core is still fuzzy, still scattered, still uncertain. So what does that mean? Did the impact happen too recently for the core to reform? Did Jupiter swallow a world so strange, so different in composition, that it poisoned its internal order permanently? Or did Jupiter never have a core in the first place, and we are seeing not the aftermath of chaos, but the original state of being? No one knows. And maybe that's the lesson. Jupiter is not here to be understood, not completely, not yet. It stands as a monument to what science cannot yet explain, a world whose very nature breaks the models we built to explain it. A planet that throws our certainty back in our face, not out of cruelty, but out of scale. It is too big, too deep, too old, too strange. And so we orbit, we measure, we simulate, and we learn, slowly, patiently, knowing full well that some answers may take centuries to arrive if they arrive at all. But maybe that's why we're drawn to Jupiter in the first place, because it reminds us that even within our solar system, there are things we don't yet understand. That mystery is not reserved for distant galaxies or parallel universes. That right here, just beyond Mars, lies a world as alien as any we could imagine. A world where rain is made of ammonia, where lightning burns through metallic skies, where the ocean is not water, but hydrogen, where the core is not a place, but a state of uncertainty. A world where the laws of physics do not break, but evolve. And perhaps the most profound realization is this: Jupiter is not unique. In the thousands of exoplanets we've discovered, many are giants like Jupiter. Some are larger, some are hotter, some are closer to their stars, others farther. And many of them are just as strange, just as layered, just as impossible to define. So what if Jupiter is not the outlier, but the standard? What if our little rocky Earth is the rare exception, and Jupiter-like giants are the norm across the cosmos? That changes everything, because then Jupiter becomes more than a curiosity. It becomes a prototype, a Rosetta Stone, a guide to understanding the architecture of countless star systems. And its mysteries? They become not just puzzles, but previews a glimpse into the fundamental mechanisms of planet formation, of fluid dynamics on an unimaginable scale, of pressure as a sculptor of worlds. In the end, what we've found on Jupiter is not a set of answers, but a new way of asking. Not a solution, but a new kind of wonder. Because Jupiter is not what you think. It never was, and maybe it never will be. It is a question disguised as a planet, a mirror made of clouds, a cathedral of motion, lightning, and silence, a collision with the unknown that continues, even now, and when you look up into the night sky and see that small, bright dot glowing near the moon, remember, that dot is not just a planet, it is a furnace of paradox. It is a monument to scale. It is a secret, waiting patiently for us to evolve enough to hear it. Jupiter does not speak in words. It speaks in storms, in tides, in magnetism, in gravity, and one day, if we keep listening, it just might tell us how the universe really works. There are no roads on Jupiter, no valleys, no mountains, no shores, no footprints, and yet it moves us. It spins like a prayer, 10 hours at a time. Its storms churn with the memories of billions of years. Its mass bends space. Its magnetosphere wraps moons in fire. And it does all this not with intention but with presence. With gravity, we name it after a god. Rightly so, because Jupiter is not just a planet. It is the first great act of planetary formation, the eldest child of the Sunday, the silent architect of the solar system's rhythm. Without Jupiter, Earth might not exist. Mars might have grown larger. Saturn might have wandered away. The asteroid belt might have become a planet or a threat. Everything we are may depend on Jupiter, and yet we barely understand it. Its core is a mystery. Its winds defy prediction. Its magnetic field humbles technology. Its very formation is still debated not because we lack data, but because the data refuses to simplify. This is not ignorance. This is the nature of cosmic truth. Jupiter stands as proof that knowing more does not always mean understanding more. Sometimes, new knowledge magnifies the mystery. It deepens it, makes it richer, and that's a gift, because we need mysteries. We need planets that defy explanation. We need places like Jupiter, places that remind us how small we are and how much is left to learn. So, the next time you see it in the sky, bright and unmoving, like a lighthouse for the cosmos pause, think of the clouds, the liquid metal, the fuzzy heart, the slush that rains ammonia, and the red spot that watches time pass like a god with no need to blink. And then ask yourself, what else have we misunderstood? What other worlds wait to surprise us? Because if Jupiter is this strange, this deep, this alive beneath a surface we've stared at for centuries, then what might be true of Saturn, of Neptune, of exoplanets, of the stars beyond? What might be true of consciousness, of time, of reality itself? Jupiter is more than a planet. It's an invitation to fall inward, to question upward, to listen deeper, and to embrace the truth that the universe is not made of answers. It is made of stories we have yet to tell.